I'll work another set of big microcontroller assembly instructions. Okay, so we'll talk about conditional branching, or instructions where we can do a sort of decisions. As you all know that assembly code is a sequential program, which means that each instruction is executed sequentially, or one by one. So in order to do branching, we need a sort of instruction that allows us to do a kind of jump, or skipping one, or at least one instruction or more. So with big microcontroller, we have 4 types of instructions that can be used for that purpose. So the first one is called BTFSC, which means bit test file skip if clear, and it has 2 operands. The F is, as usual, we mention F is file, which means it's a register, and B is a bit within this register. So the instruction says test the bit of a file and skip if it is clear, which means skip if it's 0. So if the bit number, for example 5 of a register, let's say status, is 0, skip. That means you need to jump. There is another instruction called, which is similar to the first one, is called bit test file skip if set. It's opposite to that other one, which means if the bit of this file is set is 1, you skip. Skip means that you jump one step. There is also 2 instructions, one for decrement and one for increment. So we have decrement file skip if 0. That means you keep decrementing a file, and if it reaches 0, the value of the file, then skip. And it has 2 operands. So F is file or register, D is the destination. And we mentioned before that D can be 0 if the destination is W, or 1 if the destination is F. There's also increment file skip F0. So basically we increment, and when the file reaches to 0, which means that the file reached to the maximum and overflow, then skip. You will notice probably in the next videos that the decrement file skip F0 is a better way to use it for looping. So basically you can have a variable with a certain value, and you keep decrementing this value until you reach to 0, then you skip the loop. Okay, so let's do an exercise. Basically I have another exercise here. In the next slide, it says use port A as an input and port B as an output, and write a program that does the following. We just correct following. Okay, reads the input numbers from port A. So port A is an input, and if the number is even, it will be displayed at port B. If the number is odd, it will not be displayed. Let me just copy the exercise, and let me go to the MB Lab. Let's create a file, project, and let's call it standalone. Next. So let's select mid-range, and we still own this B16 F84A, B16 F84A. Next. Simulator. Next. And we use the MBSM compiler. Next. Let's call it branching. why it's not back. We just go next. Okay, there's some problem here. Okay, we just get back. Okay, next. Okay, so now it's working. It's called branching. Okay, so branching project, let's make it big B project. Okay, finish. Add source file, new. Now we can say even pod, any name. Okay, so we have now the source code, the assembly file. Let me just paste and put a comment, the exercise. Okay, so this is the exercise. So as usual, we need to include B16 F84A.inc, and then we have org00, and then at the end we have end. Okay, so now we use port A as an input, so we need to go to bank, select trace A, and then we need to use port A as an input, so we can say move LW0XFF and move WF into trace A. Good. So now this is an input. Trace A now is an input, and for port B to be an output, we simply say clear F port B. Okay, so this is, we have now initialization. Let me call it just initialization. As usual, I like to call it initialization to differentiate it from the original program. Initialization. Okay. Now this is the original program, the original program, or the process of the program. So so the read input number from port A, so we need to read, so move F port A to W. Now if the number is even, it will be displayed port B. So we need to check a certain value. How we differentiate between input and output. It's just simple. If we look at the even numbers, for example, if we see, like, for example, number 10, the representation of number 10 is going to be like 0 0 0 0, then 1 0 1 0. If we see, for example, number 6, let me just put it here. Also, it's an even number, 6. Just need to look at the difference between So 0 0 0 0 0 1 1 0. So this is the even. If you look at an odd number like 5, it should be something like 0 0 0 0 0 1 0 1. If you look at number 9, for example, so 9 is, just do it this way, make them the same. 0 0 0 0 1 0 0 1. So if you notice the first bit, so this is the difference between the even and odd. So if bit number 0 is 0, it means it's an even. If bit number 0 is 1, that means it's it's odd. So now we need to check that. So what do we need to do is to use one of the condition. But we say bit test file skip. So what do we need to display? We need to display is even, if it's even. Okay, so we need to do it this way. So bit test file skip FZ port A, 0, and so basically we check if bit number 0 of port A is Z is 1, which means it's odd. Then skip the move FW port A to W. So basically we don't move this value to the W, then we have move WF port B. Alright, so this should work now. What we are trying to say, if it's odd, if it's even, then skip this part, which means we don't actually change the value of W again, and we're still displaying the previous value. Okay, let me just do sort of cleaning. First of all, we need to blank select port A, and let's just clear W, and we can actually do a sort of looping. We just do the looping here. So every time we clear W, no, we don't need to clear W, we can just keep it like this. So we have loop, then we have go to loop. Alright, so again, just to make it more clear, in this loop what we are doing is we are checking if the number is odd, then skip the next instruction. So you skip the next instruction, which means you describe loading port E or moving port E to W, which means you still moving W to port B, the previous value. Let's give it a try. Let me just save it and go to the build. Succeed, there is no errors. Let me just now do the run first, and as usual we pause it and let's reset. Okay, so start from here. Now if we go to the window debugging, let's go to the variables. I don't want to see the W register, just remove it. Delete. I want to see port A and port B. Okay, so port A is an input and port B is an output. Now both values are 0, so let me just click on F7. Now we have, so we need to have also the stimulus, so simulator stimulus. So port A is an input, which means we need to have like RA0. Let me just add 2 values or 3 values, and then RA1, and the last one RA2. So if it's high, that means this is odd, that 111 is an odd, it's number, it should be 7, which will be now, let me check. Now we have port A is 7. See, port A is 7. Now it will not display. Sorry, this is wrong. F7, clear port B. Just Control Z. Okay. Port B. F7. Now port A7 now is checking port A, bit number 0. If it's 1, which means it will skip, and port B will not be displayed, so still 0, so there is nothing, as you can see. Now let's make it even. Just make this low, port RA0, make it low. So now we have a value of 6. We check again. Now let's check. So now this condition will check bit test file port A, 0. It's even, so it will, what's wrong? No, yeah, so now it should display 6. Okay, let's do it again as an input, as a high, and let's make just this low. This is low, so we have number 1. This should be odd, and check the variable. Now 1 will be 6, it will not display, and because it's odd. Let's make it 2. Let's make this low. This is high, and we trigger. Okay, now go to the variables. F7, 2, it will display 2. Okay, so this is how you deal with the branching or conditions in order to split or make decisions about certain bit. This is enough for today, and thank you.